Okay, so we will move ahead with the next talk by Dr. Joseph Prabhu. Sir, please come on stage.
So myself, Dr. Joseph Prabhu. I have done my PhD from IIT Kharagpur in the field of CFD in marine applications, and currently I am working in IR class Indian Register of Shipping in research division, and I am associated with Hydrodynamics and Multiphysics groups. So today I will share some what all works going on in our department and how CFD we are using in our group. Yeah, this is our office that is in LND Junction. It's nearby, quite nearby. So over 400 employees we are here, and in R&D around 60 plus people are working in our R&D division. So we normally provide classifications and certification for the ships and the marine related services. And a short history of our organization. So IRS was formed in 1974 as a public limited company to provide classification and certification service to the maritime and allied industrial sector globally. So this is formed by the initiation by the Indian government in order to support our Indian flag by the certifications to the maritime services. So initially it was VRB land occupied by the land of the ACA Corporation nearby. Later it was handed over to Indian Register of Shipping, and after that we are providing as an independent body. So it's a not-for-profit organization, and IRS doesn't receive financial grant from zone. It makes its own revenue by its operations. So we have few offices in India and outside India. So 26 in India and 27 26 outside India and 27 in India. Almost all ports we will be having one small office, and head office is in Powai. So can see in our major research activities what will happen in our group, hydrodynamics and ship structures, where I am linked to, then vibration and noise, then corrosion fatigue, then rule development. We make the rules that need to comply by the ships and ports and harbors. Then formal safety assessment, then development of new engineering tools and methods, softwares, then analysis of data from ships in service, then multiphysics. Other than CFD, we have infrared signatures, some kind of other activities we also deal with. So I will be talking more into the CFD. So CFD, actually that IMO, Indian Maritime Organization, has made new regulations like energy efficiency index. That's very, by 2015 there is no zero carbon emission policies towards. So every existing ships and upcoming ships to be built with this energy efficiency index value should be in the limitations. So if they are not able to meet this, that they need to comply with some, fit some energy efficiency devices and increase the efficiency of their shipping and propulsions unit. So here every owners will come and approach our service in this case to provide this efficient. So CFD, the IMO has said you can perform CFD and validate your vessel whether it is complying or not. So sea keeping and maneuvering analysis. So sea keeping we will do the ship motions, and maneuvering we do for zigzag and maneuvering capability of the vessels. Then propeller cavitations. So in order to minimize the noise in the propeller, so you are an underwater radiated noise. So as IMO is again concerned about the underwater radiated noise that will be disturbed by the aquatic animals. So that should be also in limitations. Then ship airway. This we will do for specialized for naval vessels, where halo operations, where aircrafts are landing. So the airway from the upstream should not be follow into the halo operation areas. Then other than CFD, multiphysics and specialized analysis for naval vessels. It's underwater noise, electromagnetic signatures for naval vessels. Our vessel should be not throw any signatures, and underwater blast. So these are the other tools we'll use for computing these services. So ship resistance. This is our kind of day-to-day work. Every ship's need to comes for plan approval to us. So we need to validate their reports using our, we need to compute the resistance, whether they are meeting with their effective propulsion is fine, and whether they are able to achieve the proper speeds. So this we will be, currently we are using CCM, and partially this is a multi-phase two-phase flow. So partially we will be doing even foam also in this. So next part of it will be open outer to compute the open outer characteristics of propellers. So how the propeller will behave behind the ship. So that at what RPM it should be operated and efficient operate, what will be the efficient operation of the propeller, that need to be computed. Then self propulsions. So here we will be, finally we will be rotate the propeller, and the propeller forces will be transferred to the body, and we need, finally we will need to arrive with the what will be the reference speed power curve, I will say that. So from there we can come, the ship can achieve a particular speed. So as per EAXA regulations, they will be operating at 75% MCR, and the EAXA value is beyond the limitations. The ship owner should go for power limitations. That will lead to, they need to reduce the speed, or they need to reduce for reduce the tonnages. So that may again produce a loss to the ship owners. So then next part we can see, there comes energy saving devices. So we can adopt some of the energy saving devices and improve the efficiency of the hull and propulsion unit, like that. So some examples are Mewis duct and propeller boss cap fins. So using that we can do, IMO has regularized, you can do first do the CFD, and you can come with the improvement of efficiency, then you can proceed further with that. So next, this is the sheet-keeping of planing hulls. So sheet-keeping we will normally do for the vessels where the passenger comfort is more concerned. So there we will be checking about the accelerations in vertical and horizontal accelerations. So this normally that some coastal patrol vessels will be doing the analysis, and if you see, then we always do for mooring part. We will be calculating the tensions in the mooring lines, whether within to the, whether the barge or the boat to be in hold in position. The next part, if you see that propeller cavitations, that we need to compute the underwater radiator noise. So as I said before, it is very keen, it should not disturb the aquatic animals and all those things. So cavitation we will be studying, and we will be using Rayleigh-Passat model to compute this. Then if you see some specialized analysis we do for airwake analysis, for this is for navy vessels. So where the airwake from the upstream should not fall in the hollow deck, where the hollow operations will be carried out. So that need to be analyzed. Then plume from the exhaust should not enter into the engine intake. So that we need to analyze at what different speeds we need to perform and different heading angles, and that to be, and finally the chafe hollow operating limits to be reported. So that's all from my side. So in part of this works are still, I am in towards moving, shifting everything towards foam. We are currently using CCM as part of it. So few part like resistance and open outer, we are able to do it in foam. But 2 years back I met Janani madam. So we are towards the making a GUI part of it. So that is the our future plan of it. Thank you.
Yeah, thank you so much, Dr. Joseph. Thanks a lot. Yeah, we look forward with another collaboration with IR class for the GUI part of Open Foam.
Yeah, sure.
Yeah. Thanks
Okay,
a lot.
fine.
Thanks a lot.
Thank you.
Thank you.